remember the preliminaries. The preliminaries of lesson 5.1, we just did a quick little, let's call it a quick review of what we studied before. And we came to the conclusion that anything that is in standard form can be converted into something called completing the square. That is what we're working on today. All right. And the vertex is the maximum point of a parabola when a is less than 0, and the vertex is a minimum point of a parabola when a is less than 0. And so if you think about it, if a is less than 0, then we have a parabola that opens down, and I call that a sad parabola, and we're saying that that is a maximum. Okay, now if a is greater than 0, then what I tend to do is I graph a little thing like this to remind me that we're looking at a minimal value. Now, let's move on to our chapter lesson for the day. Now, on your sheet, you're going to have y is equal to negative 2x squared plus 12x plus 5. And what I want you to do on your sheet, make sure that your equation matches mine. This is example 1. I think there was a typing error, and I want that fixed. So now, when we do this problem, we're going to go and take this equation and convert it into vertex form. So there are about 4 steps we have to go through. The first thing that we have to do is we're going to have to group the first 2 terms, i.e. the x terms, the x containing terms, and we're going to put those in brackets. So we write y is equal to something plus 5, and we put our values in here. The next thing that we're going to do is we're going to factor out the a value that's sitting in front of this problem. So we're actually going to pull out the negative 2. In essence, we're just pulling out the GCF, the biggest GCF we can from this. Now, the problems that we have, there'll always be a GCF. Sometimes in more difficult problems, there won't be. There won't be a nice divisor between the 2 x's that are there. So now we're going to have y is equal to negative 2. And then we put our stuff in here, right? And what should happen is when we pull out a negative 2, we end up with x squared minus 6x. And you'll notice that I've underlined the minus 6x. The next stage of our problem is this weird thing that I think you guys will freak out for. Mr. Simpson's favorite rule is adding 0 to something. Now, oh, don't forget the plus 5. Now, in order to make a perfect square, this is, if you look at x squared minus 6x, the way this could be a perfect square, i.e. completing the square, would for us to have some number in here that when we square the first and square the last and multiply and double, we get the middle term, negative 6. So, in order to do that, what you're going to do is this. Follow this step here. We're going to make a perfect square by taking half of the b term. So half of the b term is negative 6. So we're going to take it. We're going to take negative 6, and we're going to divide it by 2. Then what we're going to do is it says we have to square it. So negative 6 divided by 2 squared is equal to negative 3 squared, which equals 9. Now, what this does, this 9 value that we're using, we're going to add it and subtract it in our square, we're going to add it and subtract it inside our red brackets. So what you have here is y is equal to negative 2, and then we have x squared minus 6x. And here's the thing that freaks people out. You shouldn't be frightened. We have plus 9 minus 9. And then we still have our plus 5 outside our bracket. Now, this whole thing here that I have here, everything up to the plus 9 is what we would call a perfect square. The minus 9 is something that's offensive to us. That thing needs to go. So imagine we have our minus 9 and we want to take it and we want to push it out to the end of our equation that we have here. Essentially, what we're going to do is we're going to add the result of the minus 9 and the minus 2. So let's go and talk about what the second last step is. Now, you're going to take that subtracted number of negative 9 that's inside that bracket, and we're going to move it outside our bracket. So this is what you're going to get. You're going to get y is equal to negative 2, and then you still have your stuff from before inside our bracket, which is our nice perfect square, because if you take a look at this, square root of x squared is x, square root of 9 is 3, 9 times 3 gives us 3x, multiply it, we end up with minus 6, perfect. It is a perfect square. And then we still have our plus 5, but our issue is the brackets. So I'm actually going to put some brackets here. I'm going to put a plus sign. And then what we're going to do is we're going to put some brackets where all this information's going. So remember, there was a minus 9 in our bracket, and we pulled it out. Now, when we pull it out, it's going to be affected by this thing, the minus 2. So we end up with this in our bracket, minus 2 times minus 9 as our extra that we've taken outside of the bracket. And that ends up being 18. So if I take a look at this result, you know that this part here is a perfect square. So I'm going to tell you what the perfect square is. It's x minus 3 all squared. Now, for this thing, the minus sign tells us what our middle term is going to be. It's going to be minus 3. And we already know the pattern for a perfect square. Now, this part here, the end, this part here is negative 2 times positive 9, which equals what? Oh, that equals 18, isn't it? What's 18 plus 5? 18 plus 5 gives us 23 plus 23. So in this case, if I was looking at this problem, my vertex would be, for the parabola, would be 3, negative 23. It has a stretch of 2. It's opening down, all that other business. And we're good to go. There's not much left to do other than that. That is the crux of all our problems today. We've just spent some time going over it. Take a moment, review it, and then you're going to do example 2 on your own. And then I'll put that up.